Hello, this is the lecture number 4 for the chapter binomial theorem, and we were discussing the exercise 8.2 and we have done up to question number 2. Now in this question number 3 you have to find the journal term of this x square minus y raised to power 6. So we know the formula for the journal term is, we have already discussed that tr plus 1 is equal to minus 1 raised to power r combination of nr x raised to power n minus r and y raised to power r. This is a journal term formula. So tr raised to power 1 is equal to minus 1 raised to power r combination of nr, n is 6 here, x raised to power n minus r. In place of x we have x square, in place of n we have 6 minus r, and y raised to power r. So it will be x raised to power 12 minus r, y raised to power r, because we don't know the value of this we don't know the value of r, so it will remain as it is. So similarly in the question number 4, x square minus yx raised to power 12, you have to find the journal term. So in place of x we have x square, in place of y we have yx, and in place of n we have 12. So tr plus 1 is equal to minus 1 raised to power r, combination of nr, in place of n we have 12, x raised to power n minus r. So in place of x we have x square, and y raised to power r. So in place of y we have yx. So simplify as far as possible. So it's coming out to be x raised to power 24 minus 2r, y raised to power r, x raised to power r. On addition, when the same, on multiplication, when we have the same base, that is x and x, the power of there will be added. So 24 minus 2r plus r, so it comes out to be 24 minus r, y raised to power r, and combination of 12r minus 1 raised to power r will be its journal term. So we are using this formula to find the journal term of any binomial for any positive integer. Now in this x minus 2y raised to power 12, we have to find the fourth term. So when you have to find the fourth term, you have to always write in the form of r plus 1, that is journal term r plus 1. So for 4 you can write 3 plus 1, therefore the value of r will be equal to 3. Now we know the value of n, we know the value of x, we know the value of y. So here in place of n we have 12, in place of x it is x itself, in place of y we have 2y, in place of r we have 3. So its journal term is minus 1 raised to power r, combination of nr, x raised to power n minus r, or y raised to power r. Now simplify combination, 12 factorial upon 3 factorial, and 12 minus 3, that is 9 factorial. Simplify as far as possible. So this is how you will find the any term or the journal term of the binomial expansion for any positive integer. Similarly in question number 6 you have to find the 13th term of this 9x minus 1 upon 3 root x raised to power 18. So you have to find the 13th term. So for the 13th term you can write 12 plus 1, therefore r will be equal to 12. So in this you use the journal formula, that is minus 1 raised to x minus y, y raised to power r. Its journal term is r plus 1 minus 1 raised to power r, combination of nr, x raised to power n minus r, y raised to power r. In place of n we have 18, in place of x we have 9x, in place of y we have 1 upon 3 root x. So minus 1 raised to power r, combination of nr, that is 18, 12, x raised to power n minus r, that is 9x raised to power 18 minus 12, and y raised to power r here is 12. Simplify as far as possible. So for combination 18, 12, it is 18 factorial upon 12 factorial into 18 minus 12, that is 6 factorial. 9x raised to power 6 means 9 raised to power 6, x raised to power 6, 3 ki power 12, and root x ki power 12 is x raised to power 6. X raised to power 6 will be cancelled out with x raised to power 6, and simplify, you are getting 18564, its 13th term. So up to this question 6, we have discussed how to find its journal term, how to find its term, how to find the coefficient of any term in the binomial expansion. Now in question number 7 you have to find the middle term of this binomial expansion. Now 3 minus x cube upon 6 raised to power 7, you have to find its middle term. First of all, you see the power of this binomial, which is 7, that is odd. When the binomial has odd power, then it will have two middle terms, and the number of that middle term is n plus 1 upon 2 the first middle term, and n plus 1 upon 2 plus 1 is the next. So replace the value of n as 7. So 7 plus 1 upon 2, that is the fourth. Naturally the next term will be fifth, or rather put in this formula, that is n plus 1 upon 2 plus 1, which will give the fifth term. So its fourth and the fifth term will be its middle term when the power of the binomial is odd number. Then it will always have two middle terms. So you have to, it means its middle terms are fourth and fifth. So find its fourth term and the middle term, fourth and the fifth term, and the term we have already have discussed how to find. To find the fourth term, you have to write as 3 plus 1. So the value of r will be equal to 3. And find its fourth term, that is minus 1 raised to power r, combination of nr. In place of n we have 7, r is 3, x raised to power n minus r, so in place of x we have 3, and y raised to power r, and y is x cube upon 6 raised to power 3. So simplify it, you will get its first of the middle term, which is the fourth term, that is minus 105 upon 8 raised to power 9. So the next middle term of this binomial expansion is the fifth term. For the fifth term, you write 4 plus 1. So therefore, the value of r is 4. So its fifth term is minus 1 raised to power r, combination of nr, x raised to power n minus r, and y raised to power r. Here the n is 7, r is 4, x is 3, and y is x to the power 3 upon 6. Simplify to get its next middle term, which is the fifth term. So its middle term, two middle terms are minus 105 upon 8 x raised to power 9 and 35 x to the power 12 upon 48 is the next middle term of this. So whenever the binomial expansion has odd power, then it will have two middle term. In question number 8, again you have to find the middle term. Here the power is even. When the power is even, then it will have only one middle term, which is obtained by using the formula n by 2 plus 1. n by 2 plus 1, and here is 10. That is 10 upon 2 plus 1. That is the sixth term is the middle term of this binomial expansion. Naturally, when its power of this binomial is 10, so it will have 11th term, and for the 11th term, 6 will be its middle term. So it means you have to find the sixth term. So T6 you have to find. So for 6 you have to write r plus 1, that is 5 plus 1. So the value of r here is 5 and n is 10, x is x upon 3, and in place of y we have 9y. To find its 5 plus 1, that is combination of nr, x raised to power n minus r, y raised to power r, which will give its middle term, which is the sixth term. When its power is 10, that is, then the power is even, it will have only one middle term. So this is up to question number 8. We have learned to find the middle term, any term of the binomial expansion, the coefficient of any term, and the general term of the binomial expansion. Now in question number 9, read it very carefully. We have the binomial, that is 1 plus a raised to power m plus n, and you have to prove that the coefficient of a ki power m and a ki power n are equal. You have to prove that the coefficient of a ki power m and a ki power n are equal. So whenever you have to find the coefficient of any term, you have to always find its general term. The general term is tr plus 1, which is equal to combination of nr, x raised to power r. For the general term 1 plus x raised to power r. For the general term 1 raised x plus raised to power n, its general term is combination of nr and x raised to power r. General term is combination of nr, x raised to power r, when the binomial is 1 plus x raised to power n. So we have in place of n, m plus n, r, a raised to power r. Now what you have to obtain? You have to obtain the coefficient of a ki power m and a ki power n. When the coefficient of a ki power m will be when a raised to power r will be equal to a ki power m. So first of all, put a raised to power r is equal to a ki power n, m for the coefficient of a ki power m, and for coefficient of a ki power n, put a raised to power r is equal to a raised to power n to get the value of r. So in this coefficient of a ki power m, the r will be equal to m. For the coefficient of a ki power n, r will be equal to n. So the coefficient of a ki power m will be obtained by replacing the value of r with m. This will be the coefficient of a ki power m. Coefficient will be by deleting this term. replacing the value of r. Similarly, for the coefficient of a ki power n, replace the value of n by r here. So it will be combination of mn n when the coefficient of a ki power n required. So you have to prove that these two are equal. Simplify by using the combination formula, which is n factorial upon r factorial, n minus r, that is n factorial. This is for combination of m plus n, m factorial, r factorial, n minus r, that is m factorial. So these both are same, which is the coefficient of a ki power m, and this is the coefficient of a ki power n. They both are same. So therefore the coefficient of a ki power m is equal to coefficient of a ki power n. So whenever you have to find the coefficient of any term, first of all find its journal term, put it equal to the term whose coefficient is to find, that is whenever you have, here you have to find the coefficient of a ki power m, so put it equal to a ki power m to get the value of r. This type of question we have already done in the first and second first question of this exercise in the last lecture. So this is the question number 9. Now in question number 10, somewhat lengthy and important question, and this will be we will discuss in the next lecture. Thank you.